So let's look at the HSF. How many atoms are bonded to this S? 2. Very good. 2 bonded to the S here. F and H are both bonded to the S. How many lone pairs are there here? No, not one lone pair. 2 lone pairs. Remember that each of these is a lone pair. So 1 lone pair, 2 lone pairs. So 2 bonded atoms and 2 lone pairs. Anybody give me the shape of that? Angular, very good. And can you give me the angle? I remember we did cross that one out for the angular. It should be 104.5. We kept the one in parentheses for it. You see it? So we kept the one in parentheses for it, but we crossed out the 109.5. Good, good. Last but not least, how many bonded atoms on the nitrogen? Louder, Ka? How many bonded atoms on the nitrogen? 3, good. And how many lone pairs? Try again. Just one lone pair right here, this guy. That's a lone pair. Somebody give me the shape of it then. Trigonal pyramidal, very good. Or trigonal pyramidal. Trigonal pyramidal. And the angle? 107 degrees. 107 degrees. Good, good. All right, we also asked you to do number 4. Let's take a look at number 4. So with these, we have multiple bonds. So we have C in the middle and N and H. 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14. We have 14 showing, but we only have 10 available. 1 plus 4 plus 5. So that means that we need 2 more bonds on this. We know we're not bonding the hydrogen because hydrogen is good with 1 bond. We're going to bond the C and N together. What that means is anytime we put another bond on there, we've got to get rid of the lone pairs from each. So 2, 4, 6, 8, 10, 12. We still are 2 over. So we need another bond added between the 2. You get that right there. Let's try this. How many atoms are bonded to the central atom? 1, 2. Even though we have multiple bonds between carbon and nitrogen, there is only 2 bonded atoms on the central atom. The carbon itself has 0 lone pairs. So it's 2 bonded atoms, 0 lone pairs. That is linear. That is a 180-degree shape. You can see that remember the valence shell electron pair repulsion, there's no electrons here to push that either up or down. So it's going to be 180 degrees linear. I've been making with models some of these. Let me make one of these with the model. So there's our hydrogen and our carbon, right? And here's our nitrogen. So remember our tetrahedral arrangement, we've got something very quite 3D. With this hydrogen cyanide, take a look. There's two bonded atoms to the central one. The fact that all of these electrons are part of that triple bond keeps that pretty rigid right there. Keeps that linear. See how it's in the shape of a line? Let's try C2H4. Now this one was difficult because we did not really have a center. So we're going to go with two center pieces. One of the things that was asked in class yesterday is, how would you know that? Well, keep in mind that nature likes symmetry. So if we imagine this is one half and this is the other half, we have 4 hydrogens. Instead of putting a bunch of hydrogens on one, we're going to spread this out. And I think the word I used yesterday was butterfly, right? So if you take a look, the problem still lies that carbon does not have the octet. So we need to give it each of those the octet. We're going to see we have 8 electrons plus 4 electrons equals 12 electrons. 2, 4, 6, 8, 10, 12, 14. We're 2 over. So that means that, well, if we recall, carbon likes to have 4 bonds, right? Currently, each of these carbons only has 3 bonds. We're 2 over. So we can make everybody happy if we give these carbons 4 bonds or a double bond, and then remove the extra lone pair. Let's see if I can make this shape. Here we go. The cool thing about this shape is we have each carbon has 1, 2, 3 bonded atoms and 0 unshared pairs. So if we look at just that part, we get a triangle, and it is on one plane of existence, one flat plane. So that is trigonal planar in existence. Next one, carbon monoxide. So we have 4 plus 6 equals 10. If we go all out here, 2, 4, 6, 8, 10, 12, 14. So 14 minus 10 is, we are 4. That means we need 2 more bonds. So 1, we take away the electrons that 1 set from each, and 2. Oh, carbon monoxide. Another difficult one here, but if we think of symmetry, basically what carbons will do is they will form a chain. We have 1, 2, 3 C's. Again, we have 4 H's. So let's think symmetry. One, two, three, 1, 2, 3. Sometimes you might be able to see, hey, this carbon here and this carbon here only have 3. They like 4. This carbon right here, it only has 2 and it likes 4. We can make everybody happy by just doing that. Maybe then we won't have to go and backtrack and say, oh, well, we have too much electrons showing. Let's check. 2, 4, 6, 8, 10, 12, 14, 16. 3 times 4 is 12, plus 4 equals 16. So there we go. Cool. That was the assignment for last night, right? Yeah. All right. Cool. Let's take a look here. Actually, it's new notes, draw this structure. I took a look again, connect the atoms together, keeping in mind that nitrogens like to be in the center. So form the nitrogens together first. Fluorines only get one bond, so they're going to be on the outside. Now, this does not look as much like a butterfly as the ones I drew. I was a little bit more artistic and kind of shifted these out here. But this is acceptable for you guys. This is acceptable. Let's try this C2H2, CCHH. Let's try to use our ideas. Let's not do any electron counting yet. Let's just look. What do you guys think about these carbons? Do they have the right number of bonds that they should have? No. Each carbon should have 4. Each one of these carbons only has 2. So can anybody think of a way that we can give both of these carbons 4? I'm sorry? Yeah, let's put another one. So now each one has 3, but they still want 4. So what can we do now? Each carbon still only has 1, 2, 3 bonds. 1, 2, 3 bonds. Give them one more. 1, 2, 3, 4. 1, 2, 3, 4. That's one of the cool things about carbon is carbon almost always has 4 bonds. So you can look at it, and that saves you time because, well, we have 8 plus 2, 2, 4, 6, 8, 10, right? Then we don't have to go back and sit there and go, oh, I need to make this a double bond because I'm showing too many electrons. The way to make it a little bit faster. All right. Major topic today is ions. Ions follow the same rule that they always have. Ions have either gained or lost electrons. If they've gained electrons, their charge is negative. If they've lost electrons, their charge is positive. So NH4 has a positive charge. That means it's lost 1 electron. So when we add this up, 5 plus 4, we subtract that 1 electron that it lost. So instead of being 9, it equals 8. Nitrogen's in the middle. Hydrogen's all around. 2, 4, 6, 8. Here's the one thing that people will forget about ions is you need to put brackets on them and put that charge right up there. If you don't put brackets on them and put that charge up there, somebody's going to say, hey, wait, 2, 4, 6, 8 electrons are showing, but we should have 9 electrons because nitrogen and hydrogen, they add up to be 9. By putting this bracket and this positive here, you're telling somebody, oh yeah, but remember we have to subtract 1. 2. Let's try this CO3, that might be fun. So CO3, 2 negative, C in the middle, O, O, O. Carbon is 4, plus 6 times 3 is 18. That equals 22. But remember, it has a -2 charge. Since it's -2, that means it's added electrons. So we're going to add 2 to that. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, oh, wait, what's that? 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Am I not counting this right or am I? One more time. I'm going to start in this corner. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay. So there's 26 being shown here. I don't have 26. I only have 24. So what does that mean we need to do? Another bond, right? Yeah, we need another bond. I'm going to put it right there. So then again, we take away one here and one here. Come on, you. Am I out? No. For some reason, it doesn't seem to be working very well. Oh, yeah. I just ran out of this. Wonder if that's the first one I've ever gone all the way through. Do I have any more? Nervousness. Let me grab one. Some over here. Boom. So there we go. Let me ask you this. Why did I choose to put it on the bottom of? I could have put it on this O, couldn't I? I could have put it on this O. In reality, this is a thing called resonance. And if we were to do this correctly, we have to draw all three possibilities. That's resonance. Basically, what resonance is saying is that double bond could be between any of those. In reality, those electrons are going like a ceiling fan. They're moving and they're switching and they're changing anywhere they can go. That will allow them to do that. That's called a delocalization of electrons. Cool. Try SO4 on your own. SO4 2 negative. Give it a try. Who's in the center? Where are they going from there? Why can't I still print? Give it a try. Give you a few seconds. It's real weird. Let me print. Let me print. It is having none of it, Ka. There we go. I'll get out a drink real quick. Be right back, then we'll show that episode 14. Who's in the center? S. S is definitely in the center. O's for days. The fact that we have the -2 up here means we do what? Well, it says 2 negative, right? So we add them. What is 4 times 6 is 24. So that total is 30 plus 2 is 32. Oh, here we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. There we go. H3O plus. O in the middle. H. Boom, boom. Actually, we have H3O plus. Let's do this. We have 6 plus 3 minus 1. That equals 8. Good. So we have 2, 4, 6, 8. I don't want to forget. I need to put the brackets around there with the plus sign. It just came up. Now, let's not bother. So what I want to do real quick is I want to go through this one and this one, and I want to go and tell the shape of them again. We'll deal with resonance another time, because the last thing that will be on the quiz for Monday will be you being able to do these shape things. So let's take a look. Make sure you have this ready. And what do we have here? How many bonded central atom? How many elements are bonded to the central atom of this NH4? Four, right? There's 4 hydrogens bonded to this nitrogen. We have 4 bonds. How many unshared pairs on that guy? None. So we have 4 bonds and 0 unshared pairs. That shape is tetrahedral, and that angle is 109.5. 109.5. How about this guy? How many bonded atoms are there on the O? 3, right? There are 3 hydrogens bonded on this O. How many lone pairs does that O have on it? 1. What has 3 bonds and 1 unshared pair? Trigonal pyramidal. The angle is 107. Now, to tell you the truth, if we were in person in class, you would have to have this memorized for Monday's quiz. That's not going to be able to be a requirement now because you'll all be home and I'll be in some meeting, right? So you'll be able to use that, but keep in mind that this is all it is, right? I mean, you sit here and you count up how many atoms are around it and how many are around it and how many lone pairs it has. So let's take a look here. Skip this one for now. Skip this one for actually. Let's do this one real quick. Number 8. Who's in the center? B, because of uniqueness, right? So now we have all these rules that we can sit there and go, oh, well, this rule applies now. H is for days. So we have B, which brings how many to the party? B is in group what? Nope, that's not 5. It's hard to see. That is 3. B is in group 3. So that's 3 plus 3 equals 6. Well, how many electrons do I have showing? No. How many does each of these lines have? No. 2, right? So I'm showing 6. Each of these bonds is 2 electrons, right? So 2, 4, 6 electrons showing. I have 6. So I'm done. I don't have any more electrons to do anything with. Why is that weird though? What is boron not doing that we don't expect it? We expect something different. Boron is breaking the octet rule. There's nothing I can do about it. If this compound exists, it must exist like this. I don't have any more electrons to give. I can't give double bonds or anything. Boron is just breaking the octet rule. How many hydrogens are around boron? How many hydrogens are attached to it? 3. How many unshared pairs are on the boron? Bond, bond, bond. Are there any unshared pairs? No. So 0. So if we take a look, it says electron arrangement and molecular geometry. So we go to this back part. This electron domain is also called electron arrangement. And this shape is the geometry. So 3 bonds and 0 unshared pairs, it exists. It doesn't seem like it should because it's breaking the octet. But that is trigonal planar for electron arrangement and trigonal planar. Trigonal planar. And trigonal planar. Now, as always, I like to include the bond angle here. The bond angle I'm going to put as 120 degrees, which it says on that back too. So what I'd like for you to do for tomorrow is 1 through 7. And I want you to fill all of this out. Tell how many bonds are on the central atom, how many lone pairs it has, and then the shape and angle of the electron arrangement, and then the molecular shape or geometry. Remember, as we replace bonded atoms with lone pairs, the shape does change from tetrahedral to trigonal pyramidal and stuff like that. Keep that stuff in mind. Other than that, if you have any questions, by all means, stick around. Otherwise, have a great day. I'm going to go grab these guys their copies real quick.